Way better. Okay. Class, here we go. 4.7. Inverse trigonometric functions. First things first, what in the world is an inverse? Inverse just means things go backwards. So we good? So let's do some inverse operations real quick here. If I say my function is x plus 4. So what happens is if I take a 3, right? If I input a 3, my output would be 7 because you're just adding 4 to it. Are we good? Good? Cool. So then my inverse, did you guys do this in algebra 2? Oh yeah, okay. So then we do this. We say my inverse function, that's a little notation for inverse. It's like a little like it's a 1 technically.
I thought it was like a negative.
Oh, sorry, it's a -1. There you go. Let's do -1. And so it's a -1 on top of a function. We good? If it was a -1 on top of a number, it would be reciprocal, right? And if it's just -1, it means -1, right? So -1, kind of crazy, guys. Real quick here. So I go like this. That guy means -1, right? This guy means, ooh, no.
Reciprocal.
Reciprocal. Reciprocal of 5, which is 1/5. We good? And then we have this, which now means inverse, right? So you got this same, what is it? The same symbol, right? Means three different things depending on the context. Okay, so what is inverse? It goes like this: 7, 3. It just goes the other way. So now the question is, can you tell me what function would take a 7 and make it a 3? X minus 4. Notice it's just undoing the work of what this did. Okay, so then trivia question. So for our trig functions, what we did is we went from a degree, is that right? So what do trig functions do? They take a degree or they take a radian measurement, right? And they convert it into a ratio. True, true. An example would be pi over 4. The function is sine of pi over 4. And anybody tell me off the top of their head, what is the ratio of the sine of pi over 4? Perfect. You guys are awesome. Root 2 over 2. Okay. That is what a function does. Inverse? We're going to go backwards now. So inverse is going to be now, I'm going to give you a root 2 over 2. And I'm going to say, I want the sine inverse of root 2 over 2. And the answer that you're going to give me is pi over 4. Perfect. Okay. Now, that's the easy part of here. Does it get more complicated? Absolutely. So let's go with it here. Next thing from algebra. Man, a lot of good stuff from algebra here. Do you guys remember? Oh, let's do it this way here. Um, there's a lot of concepts that are hitting us at once. We good? So as we go, how about this one? I'm going to create a function called x squared and see if you guys remember this from algebra. So if I take a 3, answer is 9. We good? Then I go over here and I'm going to say, okay, I'm going to inverse function and I'm going to take the 9 and make it a 3. What square root function? Oh, sorry. What inverse function does it? We have ourselves a little problem because it could actually become either a 9, we'll take it to a 3, or a -3. Oh, perfect. Okay, so what we do here is we think of this. We think of x squared being a function like this, right? And notice my 3 is here, is that right? That's what makes a 9 over here. But then also, it makes a 9, whoops, sorry, a little bit further to the right. And this happens. We good? That's our problem. We good? So what we want to do is this. We want to limit my domain of my function and then move it into an inverse function. Okay? So I say that again. So notice the positive side and the negative side give me a 9. I want to get rid of one of those sides.
X greater than 0.
Yeah, so all I'm going to do is I'm going to chop this side down. And then this way, right here, this now allows me to have only one answer going this way, right? Also, it allows me only one answer going this way. Coolio?
Yeah.
Okay, now what we really say is this. What we've done is we have made it that it passes a horizontal line test. Are we good? Craziness. Let me back up real quick here. So, doom, 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 doom. Does this pass a horizontal line test? No. We chop it off. So it does pass a horizontal line test. And now we know, here's a crazy thing about it. If we use this function and we take the inverse of it, we're only going to use the positive value, and that's a little symbol for positive value. That scratches this out. And what Ava was saying, not so much absolute value, but we define the square root only to give us positive values only. We good? Go ahead, talk to me.
But to like write out the domain requirement?
Yes, and if it does not fit the domain requirements, then we got to think about something else through it. Okay, so that's the part here. 4.7 is a little bit more brainy. We good? As opposed to like, oh, it's just this. Okay, ready. So ready. So here it is. Let's go with. Let's review the unit circle again. So we're gonna deal a lot with the radian measurements here. So radian measurements, just so we know, is 0 right here. True. And it goes this way. By the time it gets here is pi over 2. And by the time it gets over here, it's pi, and so on. We also can go backwards, right? If I go this way, what would be the measurement right here? It would be a negative pi over 2. Are we good? Because we're going the backwards way. We're going clockwise. And if I were to go up all the way up to here, this would be negative pi. Everybody agreed there? All right, now let's go. So just like we had to limit, just how we had to limit this x squared in order to have a horizontal line test that passes. And let's do this one real quick here. Remember how you guys had a vertical line test? Right? Mm-hmm. Vertical line test, just make sure that the graph that you have is a function. Are we good? Okay. A horizontal line test. Horizontal line test, make sure that when you look at that graph, the inverse is a function. Okay, so all we good there. That's probably the next concept to sort of understand. When I look at this and I pass a horizontal line test right here, I'm not saying that much about this graph. What I'm saying is the graph over here will be a function. And we need functions. Otherwise, things go crazy. We good? So I'll say it again just to make sure here. So if something passes a horizontal line test, if a graph passes a horizontal line test, that means the inverse graph is a function. Which really is to say this. That means the inverse graph will pass its own vertical line test. True?
Did we do something like this in algebra?
Yeah, We're just connecting a whole bunch of dots right now.
Yeah.
So this guy gets passed. That's the same thing as the inverse function here. And notice the inverse function now passes a vertical line test. If we kept this side, it would have been right here and it would have not passed the vertical line test, right? So that's kind of where you're at. So there's my 9, right? Going to a 3 and then going to a -3, but then destroys the whole concept of a function. Okay, are we good there? Lots of stuff to put in place. Ask questions now.
Really weeks about it. Like, right, the whole graph. Why does it matter that it's
That is a function? Oh, yeah, absolutely. So our world is made up of this whole concept of you can't be at two places at once or else everything breaks down. So let's say, yeah. So if I have a rocket that just blasted into space and it went like this, right at time equals 8 seconds, that rocket better be at one single place at one single time, or else we really are in trouble. Right? And so that's why. So our world is based. Oh, that's the fun part. Correct. So that's when it messes up. You can do and I'm not sure for how the math of quantum mechanics works. I probably should not speak right now on it, but I'd love to investigate it more. If you have some things that you want to look at too, that'd be kind of cool. Yeah, position of electrons is fascinating. It's pretty silly. And for some people, quantum mechanics is pretty silly. Okay, so are we good there? Okay, okay. So now let's go with it. So here it is. Da, 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 da. This is my sine curve. Question. Did this just pass? Oh, does it pass a horizontal line test? No. Okay, so here's what we have to do. So real quick here, let's do this here. Domain. Domain of my sine curve. Domain of my sine curve is from, ooh, yeah, remember the sine curve. Yeah. We do one, what is it? We do one period all the time, but technically flows forever, right? What's my range?
1 to 1.
Yeah, perfect. Okay, so notice there is a constraint on the range, but there's no constraint on my domain. But because of that, it actually does not pass the horizontal line test. So, oh, yeah, if you flip it, this is even funner. I'll show it to you in just a second here. Yeah, I'll show it to you. So here's what we got to do. Just like we did for this guy, we chopped this side completely off. We start chopping. I need this to pass a horizontal line test. Where do we start chopping? Tell me when to stop. And we could stop and we could check it again if need be here. Maybe I'll stop right here just for a second. Let me start. Let me let me start going like here. Yeah, let me keep on going. We're good there like that. We good? Okay. Let's see. Me.
Well, didn't
So no, it still doesn't pass the horizontal. Yeah, something and maybe let's chop this to the top, right? Oh yeah. When I get a maximum here, right? That'd be cool because then I don't go down. And if I get a minimum here, cool. Are we good there? So now the question is this, when does sine give me a minimum over here? And it's negative pi over 2. Perfect. And then it goes up to pi over 2. So here it is. I've just chopped this in such a way as when I'm going to draw the inverse function, it will be a function. Are we good?
Yeah.
Okay. That's crazy though, right? Because now we're limited, right? So I'll show you the inverse function in just a second here. But any questions so far? Have we passed? Now do we pass a horizontal line curve?
Yes.
Yes, but we were very, very, very limited now, right? As far as quadrants are concerned, if you go back up to here, what quadrants? What quadrants are we dealing with? We go from negative pi over 2 to pi over 2. Yeah, we're dealing with 1 and 4, but the weird one is, check this out, guys. The weird thing is the fact that quadrant 4 is not a positive angle, it's a negative angle. We good? So for sine inverse, all the negative ratios are going to be here. Oh, look at this. Aren't these all negative ratios right here? Okay, for sine, all the negative ratios are going to occur in quadrant 4, and then the positive one's going to occur in quadrant 1. Now, the only weird stuff is this. When you're going to give me the answers, you're not going to say 330 degrees. You're going to say negative pi over 6. And you're going to say negative 30 degrees, negative 60 degrees. We good? Negative pi over 4, because you're dealing with this one. Because, let's go back over here. Because notice, a negative, right? Pi over 6 is going to give me a negative, oh, sorry, yeah, ratio, right?
Um, do we have to draw these?
No, you just have to calculate them. So it will be okay. So here it is. Here's the reveal. Ready? Da 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 da. Here is the graph. If I were to switch the x's and the y's, the inverse function looks like this.
Oh. That's weird.
So let's look at the domain now. What's my domain?
So I remember 5 to
There's all the x's first, right? We just switch the x's and the y's.
6.
Yeah, so it only works from -1 to +1. If I were to say, what's the inverse sine of 2? You're going to say, doesn't work. Okay, now the range can only give us values of,
To negative pi over 2.
oh guys, this is not too fun. So if I ever wanted to get something in quadrant 3, I have to figure out a different way than this, because the only thing this is going to give me is -pi/2 to pi/2. We good? So I'm stuck in the quadrant 4 as a negative value. And then I get to quadrant 1, but that's it. Because sometimes I do want to get to quadrant 2. Sometimes I do want to get to quadrant 3. That's not going to...
Right.
No, it's still going to be a sine thing, but we're going to do a trick.
F of -1 x equals sine x.
We'll write it in just a second. You guys are super cool. Because I think it's the next graph that shows... No, it doesn't. So, yeah, it does. So, not to confuse. Yeah, let's do it here. So how do we write the inverse sine? We say y equals sine, because that's my function. And we put a little -1 right there. So there it is, that little -1 above your function name, in this case it's sine, will give us the inverse function.
Yes. Understand what you mean by singular. You like that we're gonna have to think of it in a different way to get stuck in quadrants 2 and 3.
We'll do some examples here in a second. It'll be all clear because we're cool at that. Okay, this is the picture in the textbook, which I thought was kind of helpful. So if you look at the sine function, we just chopped it, right? We chopped all this stuff right here to here, right? We chopped all this stuff to here. So if you were to actually, Maddie, what you were saying, right? If I were to draw the inverse function, notice right here, does this pass a horizontal, the vertical line test? No. Yeah, this chopping occurred right here, right? Because it chopped this off. And then this chopping chopped off all this, which now it passes the vertical line test now all the way down. Okay, we're good there.
Class horizontal line test though, so can you just flip it already and use that to get into quadrants 2 and 3?
Say that again. Ask again, please.
Just use the flipped version as a function, because it is a function past the.
This one right here?
Yeah,
Yeah, so
for it to be a function, does it have to have the inverse also be a function?
Oh yeah, so when we chop this, so this right here without chopping is a function, right? Because it passes the vertical line test. But if something passes a horizontal line test, that means its inverse is also a function. If that makes sense. And is that where you're asking?
Kind of. I switched it, but
Okay.
Yeah.
Yeah, we normally don't go backwards this way. Again, because once you have the function and you have its inverse, you're done. Okay, so let's do this here. Let's do some examples real quick here. I'm gonna grab this one right here. So exercise number uno. And then we'll do the cosine function. We'll put this together here. Evaluate. Evaluate the function. A. All right, sine inverse of 1/2. Now you almost like need a unit circle unless you've memorized it by now. Now you're thinking to yourself, okay, what my y value coming across? At what point does it give me a 1/2? And I'll let you look at the unit circle. Bless you. All right. What do you guys say? Where is that at? 5 or 6. It's right here. So notice the y value is 1/2. And then the ratio is pi over 6. Now, it does actually on the homework have to specify. It says about the function it actually does have to say in radians or degrees, because sometimes it actually will give it to you and ask you it in degrees. Here, I'm going to ask you in radians here. So pi over 6, are we good? Doo-doo-doom. Sine inverse of. Good, good.
Oh, no, I
Okay, tricky one. You guys ready? Tricky one? Tricky ones. Give it to me. Let's see. It was sine inverse of a 1 over root 2. Pi over 4. It's 45 degrees, right? How about sine inverse of root 2 over 2?
Yes.
It's the same thing, right?
I think the one over root 2 is 5 over, that's just like a numerator thing.
Say again, say again.
It's just a number.
For which one? The
No, Caitlin has to be in a circle.
say
Notice that one,
Yeah.
it doesn't say 1 over root 2 on the unit circle is what she's saying. The
uh-huh.
reason that I know that is because I have memorized that 1 over root 2 is the same thing as root 2 over 2, yeah.
That was like
That's. Okay.
that one, yeah. So 1 over
Thing, but not that it's
Mhm.
five.
But not that it's, yeah, you have to memorize that. One
You
over
know that
root
1 over root
2 is the same as root 2 over 2.
Yeah.
But I was just asking if there was something that you knew how to get that.
Gotcha, yeah. So from algebra, if you guys would go back to algebra. If you guys went to algebra, this is 1 over root 2. Notice that the denominator is not rationalized, right? Do you guys remember rationalizing denominators in algebra 2? What we do is we just multiply by this guy here. And you get yourself this. So then we're like, oh, hold on. So 1 over root 2 is exactly the same thing as root 2 over 2. It's just rationalized denominator. And this is rationalized denominator, rationalized numerator. But they mean the same thing. Okay, good, David. Is that cool?
Yeah.
So on your chart, okay, this is what I would want to do. So this chart has a root 2 over 2. But the chart that you guys have, that book uses a 1 over root 2. Is that right?
The book.
Uh-huh. Our book uses 1 over root 2. So it just depends on what the author wanted to use as kind of like the standard. It just messing with you guys. That's all.
Sounds good.
Okay, so let's go a little bit more complicated. Exercise or example, exercise 2. Look at that. Evaluate the function in degrees. Do-do-do-dum. Sine inverse of. Okay, let's do some fun stuff here. Root 3 over 2.
Degrees.
60 degrees is good. Okay, so then let's do some other ones here. How about sine inverse of yeah, of 1.
360.
Ooh, no.
Pi over 2.
It would be pi over 2 or 90 degrees since we're in degree mode, right? Degree mode. Okay, sine inverse of negative root 2 over 2. Do-do-do-dum. Do-do-do-do-dum.
3 over 14.
Ooh,
But,
No.
wait. Negative 45.
negative 45 degrees. Are we okay there? It's always the negative angle because you're going down from the 0 angle. Okay, and the last one, sine inverse of negative 1. Let's go down to the way bottom. Negative 90. So pretty much this thing stretches from negative 90 to positive 90, or from negative pi over 2 to pi over 2. That is it. Okay, are we good with this one? So that's what you're going to do in the homework here. That's what you're going to do right here.
This is already into homework, but it will make little sense for us.
Which
Very
one?
well played. The rocket science
Yeah, the
one?
one really cool. Oh,
Oh, how cool.
Yeah, maybe.
she's the one that gave the
Yeah.
Uh-huh. Oh, that's awesome. Mm-hmm.
It's kind of cool.
Uh-huh.
It's sun, right?
Aurora? I don't think Aurora.
Lights like.
Aurora is the light around the planet, I think, right? Is that Aurora?
Light, it's light.
It's
Light.
light.
Something like that.
Light in the sky or
Like
something?
stars or something.
No, not stars. Stars is something different. Aurora, I think, translates to light.
What language?
Light in sky. Because we had the Aurora
Aurora.
Borealis, right? Which is light in the sky at a certain location, right? But yeah. Translucent light too. That's cool.
Is that?
Latin, yeah. Okay, class, now your job. Ready? Can you chop this down in order to pass the horizontal line test? Where should we?
Chop everything out.
Say again.
So keep it to where there's one minimum and one maximum, and then you just chop it.
That sounds good to me, yeah.
And then
Ooh, let's check. Let's see. Where's my maximum? Right there, huh? So notice I'm going to chop here, but what's my domain? Okay, hold on. Let's do this one. Sorry, we forgot domain. Domain is from negative infinity to positive infinity originally, right? Range is from -1 to 1, right? So now let's see. As I start chopping, notice I'm not chopping. Oh, look at this. I'm not stopping at -π/2. I'm actually stopping at, oh, hold on, not 1, along my x-axis. What's this along my x-axis? 0. Okay, are we good? 0, we go down, 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 and we stop right here, right? That's minimum. Okay, so now what do we have?
for our domain.
Yeah, my chop domain now is 0 to pi. Okay. Interesting. Okay, so real quick here, let's think about the unit circle again. So if I go 0 to pi, question is, what's my domain? Actually, let's do it like this. This would be easier. Let's go this way. So this is the way your book draws it out, which I think was pretty cool. So here it is. Here's my chop, 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 right? I'm here now, right? I chopped here. I start chopping here, so from 0 to pi. So I go over here. So then I chop, chop, chop to here, right? And then here. So notice it passes the vertical line test. That's nice. But now it's like in here, in this space right there. So domain is from -1 to 1, right? But my range is 0 to pi. So what quadrants did that cover?
1 and 2.
Oh, yes. So here we go. So instead of going from -π/2 to π/2, the cosine curve actually covers here to here. Are we good there? So it covers a different set of quadrants. Are we done already? Is 11:17?
Yeah.
Whoa, okay, so let's do this here. So all the cosine functions that are positive will be in quadrant 1. All the ones that are negative will be in quadrant 2. So if I say cosine, no, we'll stop there. We'll stop there for now. But notice real quick, I do want to mention this to you. Notice the x values. Notice all the x values here are positive up until here. And then they're negative on this side, right? So notice it takes care of all the positive ones, takes care of all the negative ones, okay? We'll stop here. We're not done with 4.7. No homework yet. Once we finish 4.7 Friday, then we'll have homework. All right, guys, enjoy the rest of your Wednesday and Thursday. See you Friday.